Okay,
It was hard enough.
Okay, let's look at this first example. Okay, we're covering basically 2 lessons in one. Everyone look up, look up, look up. I'll wait for you. I'm waiting for you. Okay, good talk. Okay, this first one, a plus b, 2. This is what the formula is, okay? Same stuff that you were doing yesterday, we're doing substitution. When we look at this problem, we want to label the very first thing as x and the second thing as b. Do we understand so far?
Yeah.
From there, in this formula, we're going to substitute x for a and b for 4. So this a is going to become x. The 2 set within the formula, this one's plus, so that means this is going to be plus. And then the x again, the b, which is 4, and then the b in the end, 4. Now notice something. Your x's get put in twice, and your 4's get put in twice, okay, within the formula. And how you know to use which one is whether the problem is positive or negative. Are we clear so far?
Yeah.
Okay, now we solve it. x2, nothing to do there. Multiply these across. 2 times 4 is 8x, 8x. This is 4 to the power of 2. 4 times 4, 16. This one's done. Any questions on the first one? We're good? Okay, B. Exactly the same thing. We're looking at the fact that this is plus. Okay? So we're gonna use this same one, a2 plus 2ab plus b2, and we're gonna enter in our a and our b. So the a is 5a, and the b is just b. So we're going to enter the 5a into the a, and we're going to enter the b into the b. That's good. Anyone catch that?
That kind of like confused me.
Right? It just happens to be a b, so it's kind of funny. You're replacing b with b. All right, good talk. Okay, from here we're going to go ahead and solve this. We're going to go ahead and solve this. So this is 5 to the power of 2, which is what? How much? Yep, 25a2. And then here, multiply across. 5 times 2 is 10, a and b. It's just a, b together. There's no exponents. If there were exponents, they just come down. And then b2, there's nothing to do to it. Yes, Adrian? What's 5 times 5?
Oh, wait, what's 5?
Remember, it's not 5 times 2. It's a common mistake. It's the base times the base. Okay? Any questions on this one?
So we
No.
just leave it, we don't multiply the...
No, because this was already done. There was nothing to write here. And here, we just end up combining it. But if we can solve the number, we solve the number, bring down the exponent.
But like, yeah, that one, the 25, we just leave it like that, we don't solve it like the exponent.
As far as solving it, where 5 times 2 is 10, that's 1. We ignore the 1. So 5 times 2 is 10, and then just put the variables together. A, B. Okay, so if you notice plus, plus, right? Now this one's minus. So anytime that we have a minus in the problem, like this, the only thing that's different is we're going to write minus in front of the 2. Okay? So from here we're going to write out what our x and b is. Our a is x and our b is 7. By the way, don't worry about it's negative or positive. All you're doing is putting in the number, not if it's carrying a symbol or an operation. Is that clear?
So we don't carry the negative yet.
Don't carry the negative, just put the number in. Okay? And let me tell you why. The formula is already set up for it. The negative 2a. So if you put it in there, then you could get negative negatives confused if it actually worked out. Most of the time it's going to work out because it's negative times positive, negative times a negative. So typically it's going to work out regardless. But all you're entering is the x and the b. Okay? Okay, from here, so we're going to go ahead and do that. So our x is a. We're going to plug it in the 2 a's. And our b is 7. So there's our 7. So then we're going to solve it. x2, bring this down. Negative 2 times 7, negative 14, bring down the x. This is 7 times 7, 49. Any questions on this one? Is it pretty easy? What do you think?
Yeah.
You just need to know which one to use. If it's negative in the problem, you're using the negative 2a. If it's positive, you're using the positive 2a. That's the only part you really have to remember. Okay, let's look at D. So D has a little more going on, right? But it's still negative, okay? So that means we're going to use the minus 2a. So our a is going to be 3b, and our b is going to be 2c. Okay? So we write this out, and then we go insert this in. So a is 3b, so I'm going to enter it here and here, put it in parentheses. And then our b is 2c, so I'm going to put 2c and 2c in parentheses. And then I'm going to go ahead and solve it. We want to solve for the number first. Okay, so that's 3 to the power of 2, which is 9. And then bring down the b2. Okay? So we always take care of the numbers. This is negative 2 times 3 times 2. So 2 times 3 is 6 times 2 is 12. Just bring down the bc. Okay, so multiply all three numbers across. Then here we got to deal with the exponent. So 2 to the power of 2 is 4, and then bring down the c2. Okay? So variables never change the exponent, bring them down. You don't have an exponent that is just numbers, then you end up solving it. Like this one right here. 4 times 4, 16. Okay, any questions on this one? Are we seeing how we use the formulas? Okay, next one. So it's minus, right? So our A is A2, and our B is 4. So we write the formula, and I think it's easiest to write the formula out every time. I think it's just easiest. So A2, this one's a little different. A2 is going to be A2 in the parentheses, A2 in the parentheses, and then the B, 4, and 4. Go ahead and solve. This is A, 2 times 2, so A4, and then negative 2 times 4, negative 8, A2, and then 4 times 4, 16. Any questions on E? Okay. This is the last one. This one, in my opinion, is the easiest. This means you have a positive and you have a negative. Okay? So if we have this, we're using this formula at the end of the day. So state what the A is, it's X, and the B is 8. We're not concerned about negatives or positives because the formula is going to take care of it. So we're setting up as A2 minus 2B. We're going to take the A and insert it in parentheses, and we're going to take the 8 and insert it in parentheses. And then here, solve from it. This is just X2. That's 8 times 8, 64. Okay, any questions on that one? Any idea how we know that we use these? How do you know not to use the minus 2b or the positive 2b on this one? No. Your terms are going to be exactly the same plus and minus. Okay? So you're going to have an x plus 4 and an x minus 4. That's how you know to use this one.
So we never put the negative?
No. Because the negative is built into here. So we just put the 8 in here. The formula is taking care of that. Any questions on this one? Oh, wait. Good talk. Okay, next one, same thing. Notice, the terms are exactly the same in plus and minus. That's how you know to use this one, okay? They have to be identical, plus minus, okay? So, same thing here. Our A is going to be 3, and our B is 2y2. Please. Okay.
Peters, I'm not even doing anything.
Yeah, you are. If you're laughing and whatever when I'm trying to lecture, it's rude. Okay, good talk. Okay, so our A is 3. We're going to put it inside parentheses. Negative 2y inside parentheses. So we can solve this one. 3 times 3 is 9. And then we want to solve the number first. 2 times 2 is 4. And then multiply your exponents. 2 times 2 is 4. Yes? No, not during the lecture. Okay, any questions on this one? So the first thing you want to do when you look at these problems is see if the information is identical. Okay? Now look at what I did on your do now. I gave you examples. All right? Use D on this one, use G on this one, D on this one, H on this one. I'm going to cover 2 factors examples of what we did yesterday, and then you guys are ready to get the do now done. So here we have two terms that we're trying to find the greatest common factors. So we're 18G2 and 27G2. So we write them on top of each other. Don, you put your phone away, please. Then from there, we're going to divide. So 3 times 3 is 9, times 2 is 18, and we have 2 G's. So I factored this one out. Now I'm going to factor 27 out. 3 times 3 times 3 is 27, 3 G's. Then I'm going to box what's in common. I have 2 G's, or excuse me, 2 3's and 2 G's. So the greatest common factor between this is this solved. 3 times 3 is 9, G2. So the greatest common factor between these is 9G2. Any questions? Okay, next one, 16A, 6, and 9B. So we're going to stack them on top of each other and factor them out. So 16, 2 times 2 times 2 times 2 is 16, and we're going to have A 6's, 6 A's. Then 9B, 3 times 3, B clear at the end. Okay? Unfortunately, there's nothing in common here, so the only common factor between these is 1. Okay? And this is how you set them up. So you're going to do the same thing on these 3, okay, that you're doing on I and J. Is there any questions on any of this? You guys know how to use the negative 2A and positive 2B now? AB?
How did you get one GCF?
Oh, which one?
On the last one, so
Oh, it's always common to 1. Does 1 go into 16?
no.
Yes.
Yeah, 16.
Does 1 go into 9?
Yeah.
You're always going to have one greatest common factor of 1. No matter what the number is. It could be a fraction, decimal, it could be a negative number, it's always going to be 1. Okay? Which doesn't do anything for us. It doesn't reduce the problem at all.
Can you explain it? The whole, yeah.
This part right here?
Yeah,
Sure. 18G2 and 27G3, I'm gonna write them on top of each other. Okay? Then I'm going to start dividing this so I can get what's divisible by it. Okay? So, 3 times 3 is 9, times 2 is 18. So these are the factors of 18. Then I'm going to do 27. 3 times 3 is 9, times 3 is 27. And then I have 3 G's. G, 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 2 G's, 2 G's. Okay?
Yeah.
Okay. And then I box them so I can see which ones are in common. This 3, this G, this G. And then I total them. So 3 times 3 is 9, G2. So 9G2 is the greatest common factor between these two. Which basically, Daisy, all this is doing, you're going to see as we move on to chapter 8, that we're trying to reduce things. So if we can reduce things, we do it by greatest common factors. Even though there's variables and exponents and all that sort of stuff. Do you want me to go through this one?
No.
Okay. Nothing on that, but we still set the problem up just to be sure. Okay. Okay, are we good? Okay, so you want to do the do now. Like I said, I put letters to exactly how you should solve them. Follow D on this one, G on this one, D on this one, H on this one. Okay? And how we know, look at this. These are the same. X3 plus Y2, X3 minus Y2. These are the same, plus a minus, that makes it H. This one right here, minus, so this was minus 2A. This one right here, the symbol, it's the same, right? 5A2 plus 9, 5A2 minus 9. Okay? So we're going to use G on this one. This one, 3x minus 4, we're going to use our negative 2AB on this one. That's it. That's all you're able to tell. Is there a minus? Is it being duplicated?
For 2 and 4, we could use either one, G or H.
I would use G on this one since they're identical. Okay? But technically, Daisy, if this were written out this way, 5A2 plus 9, 2, we can't use that because this is plus twice. So we have to use plus 2AB on this one. Make sense?
Yeah.
Okay. So that means this one ends up being minus minus because it's 2. So we have to use negative 2A on this one. That's a good question now. Same thing here. Okay? Okay.
There's no F.
No, I started it and I took it out because I was going to go through another example, but I realized I covered it all. Okay, so you want to get the do now done and turn it in, okay? Show all your work. Everyone here should be able to do it. Dominique, I need it in your bag, please. Thank you.
I don't know how to do this, my book tutor.
No.